So here we go, we're going to have a look at LDR. So I've got an LED here hooked up in parallel to the speakers. So if I turn it up, so if I unplug everything, the background kind of looks like this. It's probably picking up the flicker of the indoor lights. So we know it can deal with 60 Hz. So I'm curious to find out what frequencies this thing can respond to. So I've hooked up an LED and a speaker to the same output, and let's just see what it looks like. So if you pulsed your data on and off at that frequency, you should be able to receive it. The higher the frequency, the harder it gets to actually get a good reading between high and low. Now, I don't actually need to figure any of this out, but say for instance if you did want to send data whatever bit rate you wanted from Arduino to Arduino, or from any computer to another computer via a light source, so that the two circuits are not electrically connected, I reckon you can get about 2000 messages per second at whatever length you want, as long as you've got enough sensors to receive them at the same time. Now if you multiplex them, obviously it's going to be slower. It's probably going to be more like 200 if you've multiplexed one input to 16. In fairness though, what I'm told is you would use a photodiode or phototransistor to do quicker response jobs. And you can see that curve on one side is where the delay of the charging is happening. So the curve is a few microseconds, and the length of that determines the frequency at which means how many measurements can be taken per second. So if your program has to stop to take a measurement, this makes quite a big difference, which then means that you have an opportunity to figure out what your microprocessor can be doing with those microseconds. You also get some idea of what it would be like with interference, for instance with my finger close up. So yeah, let's do that with a multiplexer. So here I've got 6 LDRs, one is to the side and I'm just touching it with my finger. You can see it's picking up frequencies, and then as soon as I put the LED there, so I'm just going to tape it on. So the frequency at which it's gonna start looking distinguishable. So let's unplug the LED and see what our background looks like. It's looking more like a much lower frequency for a multiplexer because they're not being hooked to ground in between changing to each other, so they're going to share a bit of charge. So there we go. So the LDRs are pretty quick component, but the older they get, the slower the response is, I find. Yeah, so I would say probably about 200 Hz is your sort of reliable frequency for LDRs if you've got them in a multiplexer without a ground between the sensors. So yeah, all you essentially get with a delay is slower data coming in, so that can be useful sometimes. So in a case of, say, using an LED and to use in a sensor, might be an idea to just make like a little tube. So it's looking like you really want a tiny hole at the end of your LED, but it's kind of... That was the fire alarm going off. Anyway, if you touch the wire that's generating this signal for your LED, you can become the source of interference, and then when you put your finger near the LDR, you'll get all these strange waves and patterns, which is also quite a good way of figuring out how to distance the LDR away from anything that may cause interference, so that your device is not prone to those problems. Also, as a sort of precautionary notice, in case you are becoming the source of interference, do not use both hands if you can help it. If you use both hands, then you are a circuit from your left to your right hand, and the circuit goes through your heart, and it takes 1 amp to stop your heart. Although with Arduino, it's not likely that you'll get an 1 amp load going through you, but probably better to be careful than not. So let's get a bit of cardboard and I'll poke a hole in it and see how it does. Yeah, so that's pretty reasonable. Just a tiny little hole with something that stops light, in something that stops the LED, and just have a LED move around. Pretty straightforward. Or you could have a reflector, a reflective surface. And there we go. So you could do tons of crazy stuff with an LED and an LDR, potentially, because you've got two parts that can move in quite a number of ways, and the only thing you really need to do is stop light from happening. So if I stop the light from entering that, you've got a much bigger range of, much bigger signal range. Obviously the lower the value, the more interference you're going to get. So that includes electrical interference from my hand, for instance. So let's put that low. So that's it. LED and LDR quite happily coexisting together.